Hello, students. Welcome back. We're going to be talking about algebraic limits. So we've seen limits graphically and from tables, but how do we find that limit if we're just looking at our equation? So the first method we're going to talk about is just direct substitution. And that is the most straightforward. We just plug in the value. If there's no problem at that value, as x goes to pi over 2, for example, if we're not experiencing any issues, this is fine. We can just plug in the value and we'll get our limit. So sine of pi over 2 plus 3, parentheses here. So sine of pi over 2 plus 3, sine of pi over 2 is 1, plus 3 is 4. So our limit as x goes to pi over 2 of this function would just be 4. We don't have to look at a table. We don't have to look at a graph because at pi over 2 there was no issues. Same here. If we plug in x equals 4, we have the square root of 3 times 4 plus 4. 3 times 4 is 12 plus 4. This is the same as the square root of 16, which is 4. So both of these limits actually were 4. And we had no problems at either of these. Now, you might be able to see where we could have a problem with the square root if we were to plug in like negative 10, for example. This would be negative 30 plus 4, negative 26. We can't take the square root of a negative number, at least not in calculus AB or calculus BC. We're not going to be doing calculus with complex numbers. So we would have an issue there. We wouldn't have a limit at that value, but that's something we're going to talk about later. Okay, next thing we're going to talk about is what is indeterminate. If you haven't seen this term before, let's talk about a couple other things. So if we have a number, let's say n, and we divide it by 0, I want you to think about what this is equal to. If we have 0 and we divide it by a number, I want you to think about what that is equal to. And then finally, if we had 0 over 0, what is that equal to? Okay, so you've probably seen the first two. I wrote n as our number to help you remember no. No, you can't do this. This is undefined. And then we have 0 over k, which is okay. We can do that. That's just 0. Now, the last one, 0 over 0. A lot of you, you might be thinking it's undefined or it's 0. And, a lot of people think that. Let's say it's some number b. 0 over 0 is b. If we multiply both sides by 0, we have 0 is equal to b times 0, which works. This is okay. Like this equation works. Any number times 0 is 0. So we run into a problem because b could be absolutely anything. So we call this indeterminate. Indeterminate. Now, you may not necessarily need to know that word for this class. However, you are going to need to be aware of 0 over 0. When that happens, that means there's something we can do to find our limit in a different way. Okay, so let's look at these limits below. We have the limit as x goes to 3 of 4x minus 1 over x minus 3. If we just plug in, we have 12 minus 1 is 11 over 3 minus 3 is 0. So we have 11 over 0. This is undefined, so our limit does not exist. And we might think, what does this look like? Well, a rational function where the denominator is 0, but the numerator is not. This is an asymptote. This is a vertical asymptote. If we keep going, if we plug in 3 here, we have 2 times 3 is 6, minus 6 is 0, over 3 plus 1 is 4. So this is just 0. This limit would be 0. And finally, if we look at the last one, we have 2 times 3 is 6, minus 6 is 0, over x squared minus 4x plus 3. Okay, 3 squared is 9, minus 12 plus 3. This ends up being 0 over 0. So do we have a limit there? That's the question. We didn't here when we're dividing by 0. So what we need to do is actually come down here, and we should try to factor this. So let's say the limit as x goes to 3 of 2x minus 3 over x minus 3. And just something to notice, if at 3 we have 0 over 0, if you're not very good at factoring, you kind of know that x minus 3 is going to be a factor. Like it kind of has to be if we had 0 at 3. So that kind of helps us to find the other factor. So we have x minus 3. And what times minus 3 gives us positive 3? That is negative 1. Okay, so now we can cancel and find the limit as x goes to 3 of 2 over x minus 1. Now we can plug in directly, and we get the 2 over 2, or 1. So yes, at 3, we have a problem. That function is not defined at 3. However, its limit is 1. So what we would see at the point x equals 3, we would have a hole, but it would be at the y value of 1. And I'm not going to draw this perfectly, but I'll just show you kind of what that looks like. So at 1, we would actually have an asymptote. And at 3, we're going to have a y value of 1. So there's 2, there's 3, there's 1. And I think it's going to look something like this. Okay. Okay, so the point at which I drew here, the 3, 1, we actually have a hole here. I drew a point, but that's actually a hole. So our limit from the left side is 1. The limit from the right side is 1. So our limit is 1. Okay. Multiplying by the conjugate. This is the next method for solving a limit in indeterminate form. So what we would do is try to plug in. So 0 plus 9, so we have the square root of 9 minus 3 over 0 is 3 minus 3 over 0 is 0 over 0. Okay, so we don't have a limit there, or we don't have a value there. So we need to multiply by the conjugate. We have the square root of x plus 9 plus 3. If you don't remember what the conjugate is, it is when we have a binomial, a two-termed group, and we have a minus or plus sign in between them, the conjugate would just be the same group of two terms, but with the opposite sign in between them. So x plus 9 plus 3. Okay. We have the limit as x goes to 0 of x plus 9 times x plus 9 is x plus 9. Minus 3 times 3 is minus 9. And on the bottom, we leave this alone. We don't want to distribute. We want to leave this alone. It's going to help cancel things out. So you'll notice in the numerator, the plus 9 and the minus 9 will cancel. And then we can cancel the x's. So we're left with, I'll write this below, the limit as x goes to 0 of 1 over the square root of x plus 9 plus 3. And now we can plug 0 in. So we have 1 over the square root of 9 plus 3. And this is equal to 1 over 3 plus 3, or 6. So our limit is 1/6. And finally, we're going to do the method of the least common denominator. So here, I decided to change x to h just to show you that the process is the same. So in order to combine these two fractions in the numerator, we need them to have a least common denominator. So we can do that by multiplying by 4 over 4 and by h minus 4 over h minus 4. And that will give us the limit as h goes to 0 of 4 over 4h minus 4 plus h minus 4 over 4h minus 4 all over h. Okay. The limit as h goes to 0, and we can see in the numerator, when we add these, the 4 and the 4 will cancel. So we'll have h over 4h minus 4 all over h. Okay, and this can be kind of confusing to have a fraction within a fraction. But since we're dividing by h over 1, we can multiply by the reciprocal. The limit as h goes to 0 of h over 4h minus 4 times 1 over h. And you'll see again, our h's will cancel. Okay, so we have the limit as h goes to 0 of 1 over 4h minus 4. Now we can just plug in via direct substitution. If we plug in 0 for h, we have 1 over 4 times negative 4, and this is equal to negative 1 over 16. And so our limit would be negative 1/16. Here are the most common methods for reorganizing a rational function in order to find its limit so that we can eventually use direct substitution. Thank you and have a great day.